Have is a particle starts from rest and moves in a straight line with an acceleration 25 minus 10v. Brilliant. One sec. So, quick. Okay, and then phi is the speed of the particle. Okay, after time t, find phi in terms of t. So we got I'm pretty sure we got a equals to v dt. The v dt in turn is going to equal 25 minus 10v. Next thing we're going to do after that is we're going to move everything around, so we're going to get 1 over 25 minus 10v dv equals dt. Now we're going to think of some limits for ourselves, okay? So it starts from rest, so that would mean when t is 0, v is 0, that's v, and this one up here should be t. It gives us a little trick for ln here, okay? So what it says is that when you're integrating this here, it's going to be ln 25 minus 10v, that's no bother. But then what it's going to ask us to do is going to ask us to get the coefficient of the variable. So we're going to differentiate that to get minus 10. So it's going to be 1 divided by minus 10 ln 25 minus 10v, and that's all from v to 0, and that's going to equal t.
Does the c just cancel out?
From t to 0. Yeah, c is for indefinite integrals. These have definite limits. Okay. Next thing we're going to do is work this out then. So it's going to be minus 1 over 10 ln 25 minus v. Minus the 10th is plus a 10th, and then it's going to be ln 25 because so that's 10v as well. It's going to be ln 25 because v equals 0, and this all equals t. T is, we're going to join the two of these together. We're going to take out minus the 10th into ln 25 minus 10v minus ln 25 equals t. Does one want t on its own or v on its own? Find v in terms of t. So we need v on its own. Okay. Very happy to get rid of that minus 1/10. I'll just bring it over to the other side as both sides by 10 and both sides by minus, so I'll get minus 10t over this side, and then this part here is still unaffected, so I'll get here is ln, use the division rule, ln 25 minus 10v all over 25. Okay, I remember to fix an ln. Huh? Bring the e over to your side, yeah? So ln is essentially log base e. Bring that e over to your side, so it's going to be e to the power minus 10. Then it's going to be 25 minus 10v over 25. Multiply up to 25. So 25 minus 10v equals 25 e to the minus 10. Then 10v minus 10v equals minus 25 plus 25 e to the minus 10t. Divide by minus 10 equals 2.5 minus 2.5 e to the minus 10t. Okay. So what we have next, guys, if you want I can try and move all this up into the same frame. There you go. Okay. There you go, guys. Okay. There's most of your workings there. Now what they're trying to get us to do next is find the time taken to acquire a speed of 2.25 seconds and the distance it travelled in this time. Oof, distance it travelled in this time. Why can I not just do velocity? Why am I not allowed to do a linear motion equation? Acceleration isn't constant, so that's a complete no-go for me, I'm afraid. Okay, so might be struggling with that a little bit. Now what I'm thinking is, let's find the time taken for it to get to 2.25 would be a good start, okay? So what we have is v equals 2.25. So that would be 2.25 equals 2.5 minus 2.5 e to the power minus 10. Everybody cool with that? Velocity equals 2.25. Take away 2.5 and you get minus 0.25 equals minus 2.5 e to the minus 10t. Divide by, multiply both sides by negative, gives us a positive. Divide one by the other, so it's going to be a tenth equals e to the minus 10 t. How do you isolate t on its own? ln both sides. What happens when you ln both sides? It's going to be ln e to the minus 10t. And what happens to the minus 10t? Goes to the front. What happens to the ln e that follows? Turns into 1. And what are we going to get t equal to then? T equals minus 1/10 ln 1 over 10. Is that okay?
Can you no, can you do that ln on the other side again?
Okay. I've stuck here, I have a variable stuck in the power position. When you have a variable stuck in the power position, you need to use logs. I logged both sides. I then used the power rule of logs to bring the 10t to the front. So I got minus 10t ln e. ln e is 1. Okay? Huh?
How did you bring the whole
10t to the front. Rule of logs.
But does it not have to be ln of e not have to be to something?
What?
It is to something.
Is it ln e 1?
Yes, any log to the same base is 1. Log 10 base 10 is 1. Log e base e is 1, and log base e is ln e equals 1.
How did you just move the 10t up to the front when it's
Power rule
left?
of logs.
I know that's
Okay.
the power, but shouldn't there be a 1 left over if you divide?
Pretty much behind the cell of one doesn't
To 3. See the way it's log 10 power 3?
Yeah.
Bring the 3 to the front.
Yeah.
And then you have 3 log 10. So the e was left behind because it was the base number, in the same way the 10 was left behind. Is that alright?
E, ln of e to the e.
Exactly. Max?
Can you not use that rule where you changed the first one you did at the top? Can you not just do 1 over 10 equals the e over to minus 10t?
Sure, could do it a different way, but we're just picking hairs in it at this point in time. This is the established techniques that they use in every marking scheme. Alright. So guys, ln e is 1. T equals minus 1 over 10 ln 1 over 10. Everybody cool with that? Now there's a way to fix that up a bit. I'm not too happy with it. What I'm just going to do is I'm just going to change it around a wee bit. It's going to be ln 1 minus ln 10. Where did I get that from? The division rule. I unraveled it back to subtraction. ln 1 is what? 0. So what we're going to get is 1/10 ln 10. I think it's nicer than that one. Okay, it's much shorter and nicer, okay? So I'm happy to keep that as the t value. Now, some of you are thinking UVAS, like why don't we just do UVAS, why don't we find the s value that way? We cannot do linear motion in differential equations unless it specifies that the acceleration is constant. It isn't, so that's out the window. So you'll probably ask me, how do you actually go about doing this? Well, what do we know about v on its own? V is the same thing as the STT. Would you agree with that? Okay. What is v in terms of t? We have it here, don't we? 2.5 minus 2.5 e to the minus 10t. That's v, and that will equal the STT. Everybody happy enough with that? Next thing, 2.5 minus 2.5 e to the minus 10t dt equals ds. I'm at the stage where I'm going to need a lot more board space. Okay, so that's all going to have to go. Okay. Now, what can we say about the t values? 0, and your distance covered is? You're trying to find the s value, no bother there. You can leave that as t if you can leave it as t as you want if you want, or you can substitute in the t value here. Okay, I'll just leave it in terms of t for the time being, okay? And here's what we're going to do. Once we integrate 2.5? 2.5t. Once we integrate this? The power remains the same, but then you gotta divide by the derivative of the power, which is, and all that will turn into what? Plus a quarter, isn't it? Okay, we'll take that. No bother there. Okay, t to 0, and the other side is just s from s to 0. Cool with that? What now? What do you reckon now, guys? Place it, sub it in. No bother. Take away 0, take away a quarter. What's a quarter? E to the power 0? It's a quarter, isn't it? So that's no bother. Now we have s in terms of t, don't we? So what can we do with the t value then? It's just what's it? It's a 10th ln 10, isn't it? So 22.5 ln 10 over 10. Somebody want to get that on the calculator for this for me? 10 ln 10 over 10 minus a quarter equals s. This is s. I'm just going to colour in here. That's an s. Okay. And all going well, we will get s equals 0.35, guys. So s equals 0.35, and this is because of you can also, if you look at the market scheme, you can also put it. You can also put the you can also put it into decimals as 0.23, and the marketing scheme accepts that instead of having to use the ln. Okay.